We are looking for the domain of these functions. When we're looking for a domain, we're looking for x values that will give us a problem. So for this first problem, 1 over x plus 11, well, we have a fraction. We know we can't have 0 in a fraction, and so that's could be our possible problem spot. So what we want to do is say, well, what value of x will give us 0 in the denominator? So we solve this here. So x equals negative 11. So basically x cannot equal negative 11 or we will have 0 in the denominator. So any value for x is okay except negative 11, which is represented here. Okay, so negative infinity to negative 11, parenthesis because it doesn't include balance, negative 11 to infinity, again parenthesis because it doesn't include negative 11. Okay, let's look at this next one, question 11. So we need to find the domain of f of x times g of x. We're given this f of x function and we're given this g of x function. So the domain of f of x times g of x, I know I'm going to be multiplying these two problems together. So basically the denominators are going to stay in the denominators as I multiply, right? So our final answer, I know I'm going to have negative x plus 5 times 2x minus 4. Now there could be simplifying that happens, but either way, before that happens, these two binomials are in the denominator. And so when I'm thinking of this domain, I have to consider both of these. So I can do negative x plus 5, set that equal to 0, see what x value will give me a problem there. So subtract the 5, negative x equals negative 5, divide by negative 1. So if I have x equals 5, that will give me 0 in this parenthesis or 0 in the denominator. The other case, we have to think of the 2x minus 4. So 2x minus 4, set that equal to 0. Solve. So we get 2x equals 4, divide by 2 on both sides. So x then cannot equal 2. So those are the two values that are going to give us problems, basically give us 0 in the denominator. Everything else is okay. And so when we put our answers here, we'll just put 5, 2. Okay. Next, we have f of x divided by g of x. So we have our f of x function and we have our g of x function. So we're going to have this f of x, negative 3x plus 15 over 2x plus 2, and then over the g of x function, which is 3x plus 9. So we have this original denominator right here that we need to worry about, but then because of the new function that we're creating, we also have this denominator. And so we have to take both of those into consideration, or if we want to look here, the 2x plus 2 and the 3x plus 9. So since those are both in the denominator, we are going to have to set those equal to 0 and find out what values of x would give us 0 in the denominator, which is a problem. So it can't equal 0. We minus the 2 from both sides. So 2x equals negative 2, divide by 2. So first, x cannot equal negative 1. And you can even try it in here, substitute it in, and see when you work it out if it gives you a does not exist, which it will. Okay, next, we also have the 3x plus 9 that we have to set equal to 0. So minus 9, so 3x cannot equal negative 9, divide by 3. So x cannot equal negative 3. So those are our two values that we would put in. So basically, when you're dividing fractions, just make sure whether it's an original function that has a denominator or the function that you're creating, that new denominator, so in this case the 3x plus 9, you have to take both of those into consideration for your domain because neither of those can equal 0. That can't equal 0 and this one cannot equal 0 or we will have a problem. And so you need to find the values of x that give you that. And then up here, similarly, anything in the denominator, even though it could be multiplied, things might be canceled out, we still have to consider anything in the denominator and set that equal to 0.